All right, Unit 4 review. Starting off with 1 through 4, it says use the following functions to perform the operations. So our first operation on number 1 is what?
X squared plus 4x plus 4.
Okay, so that's our first function, but I liked what I heard on the other side of the room. Addition, that's our operation. We know that with this plus sign that we can see between the f and the g. Okay, so this is the same thing as f of x plus g of x. And here we can find f of x, here we can find g of x. They tell us what they are. So we are just adding those two things together. So x squared plus 4x plus 1 plus 2x squared minus x plus 4. And since it is addition, I don't need to use parentheses. It's not necessary. Now what? Find like terms. What's my first set of like terms?
3x squared and 2x squared.
Yep, so this is a 1x squared and a 2x squared. That becomes 3x squared.
And then
4x and negative 1x, which is going to become? And then 1 plus 4. 5. That is my answer. Questions on that? Okay. What is different about number 2 than number 1? Subtraction. Okay? So the only thing that is changing is that instead of that addition sign between them, it's going to be a subtraction sign. And then I also need to remember one more thing, and what is that? Parentheses on which one?
The second one.
The second one, okay? So what we mean by that? The first one stays the same. We put in our minus sign instead of our plus sign, and now we put the second one in parentheses, just like this. Okay? What does that negative in front of those parentheses tell me to do? Distribute. So that negative is going to go to everything and just change the sign of each thing in those parentheses. So we end up with x squared plus 4x plus 1, and then minus 2x squared, then plus 1x, because a negative times a negative x is a plus x, and then negative times 4, minus 4. And now we do the same as what we did with addition, and we need to find like terms. So I've got a 1x squared and a negative 2x squared, which is going to be negative 1x squared, or just negative x squared. Then I have 4x and a 1x, which is, and then I have a 1 and a minus 4, minus 3. And that is it. Questions on that? Okay, so we're all good with f plus g of x and f minus g of x. Okay. The next one is f of g of 4. And if you remember, this is the notation that we like, okay? Because it tells us what to do. When it's written like this, okay, we can see that we have an inside and we have an outside. And we always start with the inside. So we're going to start with just the g of 4. So what I'm going to do is I'm going to go back up here. Which function is g? Do we all see it? It's the second one. And I just need to plug in 4 for g. So g of 4 equals 2 times 4 squared minus 4 plus 4. So my calculator will do that for me, but if I wanted to do it in my head, what would need to come first? The 4 squared, which is, so 2 times 16 minus 4 plus 4 would be 32 minus 4 plus 4, which is just 32. Okay, but we're not done. So what we just found there was we found g of 4 to be what? 32. So now I can just replace that g of 4 with my 32. And now what is my problem? F of 32. So that's going to give me my actual answer. So I'm going to go back up to f. It's x squared plus 4x plus 1. So I've got to plug in 32 to that. So 32 squared plus 4 times 32 plus 1. I don't expect you to do that in your head because that's going to be a pretty big number. So if you type that into your calculator, what does it tell you? 1,153. Anybody get anything different? Anybody want to double check Ryan's math real quick? Okay, so we all agree on this. Good deal. Okay, last but not least on number 4, it says g of 5x. Okay, so this one's not too hard. What do you think I would do with g of 5x? Plug in the 5x to g, right? So everywhere where you see an x and g, you're actually going to plug in 5x. So 2, instead of x, we're going to have 5x squared, minus, instead of x, we're going to have 5x plus 4. Everybody see how I did that? So that's plugging into g. I should have done it in blue because that was my g color. That was a big sigh. Okay, what comes first? Yep, the squared. So 5x squared. First off, let's do 5 squared. What's 5 squared?
25.
And then x squared? It's just x squared. Times by 2. What is 2 times 25x squared? 50x squared minus 5x plus 4. Do we have any like terms? Nope, so just leave that alone. That's just your answer. Okay. Another little just like key piece of advice is like, for instance, on 1 and 2, we had f plus g of x and f minus g of x. Do you notice how all of our answers had x's in them? Okay, but then on 3, we didn't have any x's in this problem. So we just had a numerical answer with no x's in it. Then on 4, we had some x's. We had g of 5x, so we had x's in our answer. So if there's no x's in the problem, there's not going to be an x in your answer, if that makes sense. Okay? Moving right along. We've got some more operations to do, but these are h and n of x, and they're a little simpler than the f and the g. Okay? So we'll start off with number 5. It says h star n of x. What's the star mean? Multiply. Okay, it's the same thing as a closed dot. Okay, but the computer just put that instead, which is fine. So this is the same thing as just h of x times, or star, n of x. So all I need to do is multiply h of x times n of x, right? Yeah. And I do have to remember that since it's multiplication, I do have to use the parentheses. Don't forget them. Which 2 operations have to use parentheses? Multiplication and... Ooh, not division. Subtraction. Yep, subtraction. Okay. Now what do I do with this problem? Distribute, but we actually call it, it starts with an F, foiling, okay? X times 3x. So 3, so 1 times 3 is 3. X times x is x squared. We add those exponents, good. And then we got 1x times 2. 2x. Negative 5 times 3x. And then negative 5 times positive 2. Negative 10. Okay, we're almost done, but do I have any like terms here? What are they? Yep, and what is 2x minus 15x? Negative 13x. That becomes my new middle term. My first and my last term stay the same. So that is my answer there. Questions on that one? Okay. Now we got number 6. Ooh. What does that open dot mean?
I forgot.
You forgot. Not multiplication, remember? It starts with, it's a word that starts with an O.
When it crosses the Y, no.
Order of operations.
It's a really short word. It's only 2 letters.
Oh.
Of. Open dot means of.
Oh.
So that's h of n of x. Okay? Wasn't that the same thing as this? F of g of 4? Except for this is that stupid, ugly I can't talk. Stupid, ugly notation that we don't like. So we need to rewrite this in the proper notation. So h is on the outside, and n comes second, so it's on the inside with that x. H of n of x. You with me? Doesn't that look a lot prettier? Mm-hmm. So when we have something that looks like this, we know to start from the inside. So we got n of x first. Well, don't I already know what n of x is?
Yeah.
What is it?
3x plus 2.
3x plus 2. So this is just going to be h of 3x plus 2. Don't even have to plug anything in. Well, now I do. Okay, so now we've got h of 3x plus 2. So normally, don't write this, but let's say I had h of 3, what would I do?
Just put it in
Plug it
front.
in the x.
Plug it in for the x. So now, instead of just h of 3, I have h of 3x plus 2. What do you think I'm going to do?
Plug it in front.
Just plug it in for x, okay? So what this is, h of 3x plus 2 is just 3x plus 2 minus 5. Right?
Yeah.
Because this just went in for the x, and we still had the minus 5. Okay. Yep, so now we combine like terms, as Ryan said. 2 minus 5 is going to just be a negative 3. So 3x minus 3 is our answer. Questions on that? We all good over there? Okay.
I wish it was summer.
You wish it was summer? It's got a long ways till then.
Wish it was storming so bad.
Okay. H over n of negative 4. Okay? What does h over n mean? Division. So this is the same thing as h of negative 4 divided by n of negative 4. That's not too bad. I just go and I plug in negative 4 into h. So that is just negative 4 minus 5. And then I go and I plug in negative 4 to n. That's just 3 times negative 4 plus 2. You with me? What is negative 4 minus 5? What is 3 times negative 4? Plus 2? Negative 10. So negative 9 over negative 10. Technically, the most simplified, since it's negative over negative, it could just become positive. You could also give me a decimal, give me 0.9 if you wanted to. I don't care. Okay. Last but not least, what do we notice about number 8? Open dot. So we've got to write it in the better notation. Help me out.
No.
Yep, n's on the outside. If it's in front of that of symbol, it's on the outside.
And then more parentheses x.
Yep.
2x though. Do you see it?
Same thing.
Not the same. Nope, you can't do that because it's n of h, not h of n. That wouldn't work. Okay, now we start from the
H of 2.
h of 2x. Okay, so we go and we plug in 2x for h. So it's just 2x minus 5, right? That's what h of 2x is. And now we go plug that in to n. So n of 2x minus 5 is just 3 times 2x minus 5 plus 2. And now what? Distribute 3 times 2x, 3 times negative 5. Any like terms?
Yep. 6x minus 13.
Yep, they become minus 13. Good. Questions on that?
No.
How we feel about this first page? Next one, we've got the graphs. So before you freak out, this is from a previous unit, so you should already know how to do number 9. How to graph that. Can I graph that in the form that it's in? Absolutely not. What do I need to do? Subtract the x. So minus the 1x over. So this becomes negative 4y equals negative 1x plus 8. And then what'd you say? Negative 4. So y equals, so negative 1x divided by negative 4.
1/4 x plus 8.
1/4 x
Oh, not plus 8.
minus 2.
Minus 2.
So this is my equation. Okay, that's half the battle. It's just figuring out what that equation is. Can we graph that?
Yes.
Absolutely. What's the b value? Negative 2. What's the slope?
Negative 4.
Up 1 over 4. Or down 1, left 4. And there's my line. Questions? Good. There shouldn't be a question. We should know how to do that. Okay, domain. I want you to write this down, so please make sure you're taking good notes today. Domain is your x. Always, always, always your x. From left to right. So your x-axis from left to right. From the left, where are we starting? And we're going to? Yep, left forever, right forever. Negative infinity, positive infinity. Then we got the range. That's your y-axis from the bottom to the top. Are we going down forever? Yep. Are we going up forever? Yep. So that's the same. Now, increasing, decreasing interval. This is where we look at where is y increasing or decreasing, but what we write down is where that's happening on the x-axis. Okay, so if we look, we've got Ryan coughing up a storm here, but he's running, okay? Is Ryan running uphill or downhill? He's going uphill, so is that increasing or decreasing? Would you say he's increasing forever?
Yes.
So you would call that negative infinity to positive infinity? Would you say that he was ever decreasing? No. So you would write no or none here on the decreasing. Okay, this one is probably the toughest one on the test, if I had to say. Okay? So if we look, guys, first off, domain. Even though this looks like it's kind of like very narrow at the bottom, technically this is going left and right forever. Okay, do we all see that? So domain on this one is still going to be what? Perfect. Okay? Then we've got the range, which is, again, just our y-axis. Am I going down forever?
Yes.
So that would be starting at negative infinity, but am I going up forever?
No.
Where am I ending at on the y?
0. Negative 1.
0. I heard it. On the y-axis. Remember, range is just y-axis. So we're ending at the 0. That's as far as we go. Okay? This is the hardest part here. Increasing or decreasing. And pay attention, because this is going to be on the test. Okay? This is going to be on the test. So, we've got Chase. Everybody say hi, Chase. Okay, Chase is running. What's he doing first?
Increasing.
Doesn't he stop right here increasing though? And then he starts to do what? Decrease. And then what? Increase again. He's going crazy. Now what? Okay, so he's got 4 different intervals there. Do we all see that?
Yep.
Okay. The red, where I marked the red, that's where he's increasing. So from negative infinity to where on my x-axis? -1. And also he was increasing from 0 to +1. And now we're going to look at where he was decreasing. So he started, again, he left off there at -1. And he went until he got to 0. And then he also started at +1 and went to positive infinity. So definitely study this one.
I don't see where you got it.
You don't see where I got any of that?
Yeah, you should have put me down for
One time? Okay, we can do that. So again, if one thing too that you can write down for increasing and decreasing, guys, these are your pathways on X. Okay, we already know what Y is doing because we're telling that if it's increasing or decreasing, if we're writing it on one of those blanks, we're already telling that what the Y is doing. I'm worried about where on X is this happening. So pathways on your X-axis is what I want you to write here. That's what the increasing, decreasing is. So if we look, we were increasing from negative infinity all the way to this -1. Okay? Then we started to decrease from -1 to 0. Then we increased again from 0 to +1.
Oh, I see.
And then we decreased again from 1 to positive infinity. You with me?
Mm-hmm.
Okay. We'll do another one. Number 11.
Okay.
These are going left forever, right forever, right? So negative infinity to positive infinity. My range, what's my bottom point? Am I going down forever?
No.
No, but where am I starting?
-1.
-1. Am I going up forever?
Yes.
So -1 to infinity. Okay. Now we'll do another increasing, decreasing one here. Okay.
Decreasing is negative.
Okay, so here we've got MJ. MJ's running. Okay. What was he doing first?
Decreasing.
Decreasing from
Infinity.
negative infinity to
0.
0. So negative infinity to 0, he was decreasing. Okay, then he kind of jumps down here to this line. What's he doing here?
Increasing.
From,
-1 to infinity.
okay, but this is my X pathway though. 0 to infinity. So where on X is he doing his increase? Okay, and that's from 0 to infinity. Last but not least, this one's probably the easier one besides the line, obviously. Domain is ranges. So it's y-axis, remember?
1.
0 to infinity, good. Where am I increasing? Yep,
1.
1 to infinity. Perfect. Okay. Any questions on that? Yep. We're done. We're almost done.
Confusing.
Okay.
What time is it?
We've got 2 more pages, guys. We're getting through this pretty fast. First thing here, number 13. It says, given this piecewise function, evaluate the following. Don't make these harder than they need to be. Don't plug it into every single piece. You don't need to do that. And I'm going to count it wrong if you do that. What I need you to do, here we go. First one, a of -6. What you've got to do, Look at your domain. Where would I put -6? Where is -6 defined? The top one, because it's less than or equal to -6. So I'm just plugging it into this top piece. Okay? So 2 times -6 plus 3. And these are in absolute value bars. We've done these before. What is 2 times -6?
-12.
Plus 3?
9.
Absolute value of -9, which makes it a
Positive 9.
+9. That's my answer. That's it. Okay? A of 3. A of 3. Whoop, that's not my highlighter. What piece is that going to go into? The second one, because 3 is between -6 and +5. So I'm plugging it in to the second function. When I do that, 3 minus 2 times 3 squared. What do I do first? Yep, 3 squared. What is that? 9. So this is 3 minus 2 times 9. 3 minus 18, which is?
15.
-15. Good. And then last but not least, A of 10. Where's 10 going to go? Last piece, because it's greater than 5, right? So now I just plug that in. -3 times 10 minus 6. What's -3 times 10? What's -30 minus 6? Okay. That's it for that one. Okay, then we got to graph a piecewise function. We have done quite a few of these. They're called piecewise functions because we have to break them into pieces. So our first piece is this. Y equals -2x plus 4. Our second piece is this. Y equals 5. And our third piece is this. Y equals -1/3 x plus 1. So now I'm just going to go start graphing those different pieces. But I'm going to pay attention to what their domains are, because I don't need to graph the whole line. So if I go to this one, go to a +4 for my b value, my slope is down to right one or up to left one. But I only need that for when x is less than -2. So if I go on my x-axis to where x is at -2, I only need to be left of that line where it's less than that. And then I can erase the rest. Yep. And it does have an open dot. So I don't need what's on. I'm probably not going to be super picky on that, no. Okay. And then we've got our next line, y equals 5. What does that look like? Yep, it's a hoy, right? It's a horizontal line like this. But I only need that line when x is between what two numbers?
-2.
Yeah, -2 and 3. And I already have the -2 marked. So I'm going to go put a highlighted mark on 3 as well. So I only need it between those two. Yep. You don't have to do these highlighted marks, but you can. You're going to? Okay. And then last but not least, my b value on this one is 1. My slope is down 1, right 3. Down 1, right 3. Down 1, right 3. Okay, but I only need it when x is greater than or equal to 3. So I don't need that point right there. Nice.
We can just pick the last one for test.
No, I can't do that. Yes, Nolan. Give me one more second. We got one more problem. Okay. Here we've got a word problem, okay? It sounds a little more confusing than what it is. Lena is mowing lawns for a summer job. For every mowing job, she charges an initial fee plus $6 for each hour of work. Her total fee for a 4-hour job, for instance, is $32. Let f of t denote Lena's fee for a single job measured in dollars as a function of the number of hours it took her to complete it. Okay. Sounds confusing. I promise you it's really not that bad. So they told me that f of t, which f of t or f of x, isn't that just a y value?
Yeah.
Yeah, so they told me that y stands for what? Her fee measured in dollars. So y is money, which means that this other variable, which is hours, is going to be x, right? Let's finish this up. We don't know what the fee is, okay? But we do know that it's $6 each hour, okay? So we know that we have 6x. We don't know what the b value is, but we know that y equals mx plus b. How do you think I'd solve for b?
32.
Yeah, 4 is an hour, right? So I'd plug that in for x, so 6 times 4. And 32 is a y. And now I can solve for b. What is 6 times 4? And now I need to.
Minus 24.
What does b equal? 8. So her initial fee is $8. B equals $8. Write this as a function. Y equals 6x plus 8. If she works 7 hours, what would I plug the 7 into? 6 times 7 plus 8? $50.
$50.
Yeah, she didn't do very good, did she?
No.
Okay. That is your review. It's going to be just like your test, so please, please study.